Today we're going to be looking at using Pythagoras to calculate the longest side of a triangle, or the hypotenuse. Looking at our labelling, remembering that our C is our longest side, or our hypotenuse, and our shorter sides A and B are interchangeable. We're going to look at two examples today. For the triangle below, calculate the length of the hypotenuse x correct to one decimal place. So I'm going to label our x our C, and our 4 and A, and our 7 a B, remembering that our A and B are interchangeable. And I'm going to use the C square rule, and that is C square equals A square plus B square. The next step is substituting. So A is going to be 4 and B is going to be 7. The next step is identifying the squares of those numbers. We then add them together, which is 65. Now, because I have C squared there, I only want one C. So I square root that number, and the answer is 8.06. To one decimal place is 8.1. Next question. A fire is on the 12th floor of a building. A child needs to be rescued from a window that is 20 metres above ground level. If the rescue ladder can be placed no longer than 6 metres from the foot of the building, what is the minimum length ladder needed to make the rescue? Because we have a worded problem, I'm going to draw a diagram. We know that the child needs to be rescued from a window that is 20 metres above the ground. We know that the ladder has to be 6 metres from the foot of the building. So I'm going to put all of the letters in. Remember, A and B can be interchangeable, and we are looking for C, the hypotenuse. C square rule. C square equals A square plus B square. We then substitute the letters for numbers. 20 squared is 400 and 6 squared is 36. We then add them together. But because I only want one C, not C squared, I square root 436 and we get 20.88 metres. But the question states it needs to be rounded to the nearest metre, which would be 21 metres. And that is how you use Pythagoras to calculate the longest side of a right angle triangle.